Good morning, everybody. Thank you for taking the time to attend this webinar titled ORCA, Odor Reduction Corrosion Abatement, a Smarter Approach to Odor and Corrosion Control. My name is Calvin Hurst, and I've been part of this organization for over 10 years now, going all the way back to the Siemens Water technology days. So I have the pleasure of leading the product management group for Xylem's municipal services business. My team is responsible for understanding customer needs and market trends, and then using that information to develop solutions that address those needs. So the topic today is one that is near and dear to me, and the solutions I will be presenting on were in fact derived from feedback we received from our customers, including I think some of you that are on the webinar today. So fun fact about me, just to get to know me a little bit, I am a 10-year Navy veteran. I served on a fast attack submarine out of Norfolk, Virginia in the Navy's nuclear power program. Completed 2 cruises to the Mediterranean and Indian Ocean. And before transferring to shore duty as a recruiter in Cocoa Beach, Florida, I separated from the Navy in 2009, and now I live right here in sunny Sarasota, Florida with my wife and 2 boys. So during this webinar, I'm going to provide the obligatory odor generation and impact discussion, but also get a little philosophical and share kind of my thoughts as to the good, the bad, and the ugly of odor control before getting into the real meat of the presentation. After the odor view, I'll introduce the ORCA offering, discuss points on value versus volume, and ultimately share how we've addressed metering, monitoring, and optimization of a Water One ORCA program. And then the last thing I will close us out with is a look at a couple of real-life applications of this technology and the impact it's had on our customers. But first, I'd like to start us off with a poll question. So bear with me for a moment as I start the poll. So you all can see, well, quite clearly, the interest is primarily in new odor control technologies, and secondary to that, how to achieve better results than traditional odor control programs. So moving on to the content, if we were in Vegas, I would bet that most of us on this call are familiar with what hydrogen sulfide is. In case anybody hasn't heard, hydrogen sulfide is a colorless gas that has an odor threshold as low as 0.5 part per billion and can cause nausea, headaches at levels as low as single digits part per million. Olfactory paralysis, so your ability to smell it, can set in at 100 parts per million, and conjunctivitis and respiratory irritation at 200 parts per million. Now, these are uncommon levels to see in a wastewater collection system. In Florida, it's not uncommon to see levels exceeding 1,000 parts per million. And these levels will result in unconsciousness, respiratory paralysis, and death in just a few minutes. But the health risks aside, hydrogen sulfide is also the cause of municipal infrastructure failure. The picture I'm showing here was taken during the repair of a wastewater conveyance line failure that resulted from microbial-induced corrosion. So notice how the failure occurred along the horizontal center line of the pipe. I'll kind of touch on that in just a moment. But the diagram on the left side of the screen represents the cross-section of a wastewater line half full of municipal wastewater. So imagine that this diagram is the pipe in that picture. So the wastewater is traveling through this pipe, boundary layers are formed against the pipe wall due to friction, with the water at the wall being relatively stagnant, moving faster and faster as we move from the outside of the pipe towards the center. These slower flow layers allow film to form, which is rich in biology, and this biology consumes oxygen dissolved in the wastewater for respiration. So as the dissolved oxygen is consumed, the system becomes anoxic, meaning there's no more molecular oxygen left in the system to support biology. And at this point, the biologic community shifts to one that pulls bound oxygen from other sources for respiration, typically sulfate, which is plentiful in wastewater and the precursor to hydrogen sulfide in this process. So the microbes reduce sulfate to ionic sulfide in the wastewater, and this sulfide exists in 3 forms in equilibrium, with dissolved hydrogen sulfide gas being the one that we smell as it escapes into the head space of the pipe. So in the head space, the hydrogen sulfide is then oxidized to sulfuric acid, resulting in microbial-induced corrosion. So the failure we see here at the water line is because the wastewater was washing away the corroded material, exposing virgin pipe surface to be further corroded. Understanding how hydrogen sulfide is generated allows us to develop and propose chemistries that upset various aspects of the generation and release of hydrogen sulfide. But some nuance does get introduced when we start considering how best to execute an odor control program. This slide is a distillation of customer feedback that we received with some of our own experience included. And these points have been sort of a guiding light to odor control product and program development for us. Starting with the good, the industry has a mostly strong understanding of how the various chemistries work. So a solution can be selected that best addresses a particular application. And the control effect or outcome is easy to measure, right? So there are a variety of ways to measure hydrogen sulfide in a system, both on-site and remotely. And finally, there are the variety of solutions out there that have been proven to work include calcium nitrate, oxidizers, iron salts, pH shift solutions, and many others, allowing to treat a variety of applications and select the best available technology. Now moving on to the bad, these points fall squarely into the realm of program execution difficulties. So dose rates, for example, can be difficult to optimize, and I'll touch more on this later, but as wastewater conditions are changing and are often only optimized seasonally at best. And the failure modes are many and difficult to predict. These could be things like chemical dosing pump failures, product variability, rogue dumpers in the collection system is another, or it could be something as simple as a new neighbor who moved in and is just a little more sensitive to odors than the rest of the neighborhood, or maybe they smell with their eyes instead of their noses and see that the pumping station near their new home doesn't have the odor control system that the pumping station by their old home did. Finally, the ugly refers to the impact that improperly executed odor control programs can have. Working from bottom to top, we notably have infrastructure failure. So recalling the picture of the pipe being excavated on the previous slide. Infrastructure failures ultimately lead to social and environmental impacts, whether it be a road collapse, cutting off access to a particular neighborhood, or raw sewage flowing into streets and waterways. Nobody wants to be in the news for a road collapse that prevented an emergency vehicle from getting into a neighborhood or disrupting a recreation area with raw sewage. And finally, we have the risk of exposure for the community, contractors, and utility employees, again, calling back to the table of symptoms and effects of hydrogen sulfide exposure. Add to this the risk of exposure to pathogens and the event of raw sewage release, and it becomes quite clear, why we care about controlling hydrogen sulfide. So a Water One ORCA program is specifically designed to share these types of risks with us, the vendor, and put in place solutions to guarantee compliance with hydrogen sulfide control limits. All right, so this talk was titled ORCA, a smarter solution for odor control, and the subtitle explains that ORCA is an acronym that stands for Odor Reduction Corrosion Abatement. ORCA programs are part of Xylem's Water One outcome-based service offering. So a Water One solution is a unique offering for our customers that combines key technologies with outcome-based water guarantees. So using remote monitoring and control, Xylem can provide proactive and predictive services to maintain your water needs. In the case of a Water One ORCA program, Xylem uses the combination of remote telemetry monitors and automatic dosing controllers to continuously optimize chemical dose rates and provide odor control outcome guarantees and increase visibility to program performance to maximize uptime. So what this means practically is that by using new technology, we're able to proactively monitor your odor control program, monitoring for trends and making continuous real-time adjustments to your dosing schemes to guarantee compliance with agreed upon outcomes for each of your monitoring points. So the three main points of this program are robust, reliable, and accurate dosing with the ORCA pot, and that's the picture in the top right of the slide there. continuous compliance monitoring with the brand new VaporLink 2.0 hydrogen sulfide monitor, and that's the bottom right. And then continuous optimization with odor, or our ORCA dosing optimization routine. We really like acronyms around here, and there is a story behind how we landed on ORCA that I may share if we have time at the end. But now I want to talk about the value of a service provided versus the volume of chemical fed. All right, so the unique value proposition for a Water One ORCA program is that it enables growing utilities to focus on their core operations by eliminating odor complaints and ensuring budget certainty. This is different from other odor control services that require resources, expertise, and can create volatile expenditures without guaranteeing outcomes. Xylem accomplishes this by using technology to maximize uptime, optimize dose rates, and provide real-time insight into the operation of the system. So in short, a Water One ORCA program will fix your spend, thereby eliminating variable expenditures throughout the year and guaranteeing that your program covers the full year, even the final months where price per gallon program might have exhausted your total budget, while also guaranteeing your hydrogen sulfide control limits. We're able to achieve this by expertly managing your odor control program with 24/7 monitoring, real-time adjustments, and robust uptime guarantees, all while providing visibility to the outcomes of the program. Practically, it might look something like this. So under a traditional program, the monthly spend is variable to account for changes in odor control chemical demand month to month, while an ORCA program will guarantee a flat rate month over month, regardless of changes in chemical demand. And to ensure that we have some skin in the game here, Xylem will help to establish odor control targets for each monitoring point based on your specific needs, and establish penalties for each time that we fail to meet those targets. And finally, an expert program manager will continuously monitor your program, optimizing chemical dose rates to meet the agreed upon outcomes and coordinating on-site preventative maintenance. So with that, we'll move on to the next poll question. All right, and this one is, how many times per year do you exceed your odor control limits? So sharing the results here, you can see that the majority, well, I'd say the 33% take the position that you can't exceed odor limits if you don't set them, while another 28% exceed limits 1 to 2 times per year when seasons change. Maybe that exceeding that limit is the motivation for making seasonal adjustments. 4 to 7 times per year, 17% due to unexpected changes. 11% coming in at 8 or more, but is counting, and then 11% never, ever violate their odor control targets because they've got it completely under control. Trying to move on. All right, so I'm happy to finally introduce you to our feed platform, the ORCA pod, or Precision Output Device. Again, we like our acronyms, and we're going for a theme with this one. The pod was named as such because it provides a level of chemical metering accuracy and uptime that is unmatched in the industry. This platform monitors 957 different system parameters to make decisions about how to manage the chemical dose rate and inventory. And visibility to all this information allows our expert data analysis to troubleshoot system conditions remotely. The system directly measures its metering rate, allowing it to immediately adjust to over and under feed conditions. And a Water One odor control program comes complete with 24/7 monitoring and continuous optimization and casualty response. So lastly, the ORCA pod was built specifically to maximize uptime and self-correct for low or no flow conditions. So meaning if it senses that it's supposed to be pumping something and it's not pumping that amount, it will take actions automatically to resolve the issue and adjust the dosing rate. So all these features and benefits are great, but I think my favorite really is the blending of the branding and the functionality. right? We have a black pigmented tank that prevents UV light from reacting with a variety of odor control chemicals, and a white pod that reflects more sunlight and keeping the electrical and signal components a little cooler. So it kind of looks like an ORCA. So all these features are great, and in a few slides, I'll share with you why they matter when we go over the case studies, comparing the performance of the new ORCA pod to our previous generation chemical dosing platform, the VersaDose. But first, I want to talk just a little bit about optimization. So the question here on the slide is, why is continuous optimization difficult? Well, we already talked about seasonal adjustments being the primary way that most odor control programs are optimized, but this doesn't really allow for maximizing chemical efficiency or budget efficiency. We do see changes, periodically throughout the year, and in response to certain events that are not accounted for when we just adjust dose rates seasonally. Next, continuous manual optimization is not feasible due to the personnel time requirement and the level of skill required to do it. Some of our customers might have upwards of 80 or 90 chemical dosing sites that are a part of their odor control program, and it's just not realistic to expect a person to optimize 80 or 90 sites continuously or even weekly. That becomes more than a full-time job. And there are other kind of issues that even if you have more than one person doing it, get introduced. Things like typically you're optimizing with respect to multiple different variables that are maybe at odds with each other. So I've got listed here optimizing with respect to hydrogen sulfide concentration and budget. So which do you prioritize? It leaves a little bit of room for variability based on the individual sentiment. So if you do have a team of folks that are trying to optimize your 80 or 90 chemical dose sites, if you're a large customer, how do you ensure that they make those types of decisions consistently the same way? It becomes a very difficult thing to do. So to address these specific types of issues, we have built out the ORCA dosing optimization routine, ODOR, wherein we're using advanced data analytics to optimize chemical dose rates. And we're able to do this because, again, thinking back to the good, wastewater characteristics are generally pretty repeatable, and the chemistry is very well defined, so we know when those wastewater characteristics are changing, how to affect the chemistry to achieve the odor control outcome. And then we have a history of data that we've maintained with our advanced dosing customers that allow us to build and train algorithms to have continuous optimization. And finally, it's effective irrespective of the amount of effort you put in. When we've got a system that's built specifically to do this and requires minimal interface from a practitioner, we're able to do a lot more with while imposing a lot less on technicians and utility workers. Next slide. This is another one that's pretty darn exciting for me and also relatively new. So compliance monitoring is a core part of a Water One, any Water One program, but specifically an ORCA program. So we're looking at hydrogen sulfide. We're optimizing chemical dose rates respective to changes in hydrogen sulfide. And there are a number of solutions out there for doing that. But they all come with their own, set of headaches, right? So historically, we've used a variety of off-the-shelf hydrogen sulfide monitors that had, a number of different issues. And I've got them all kind of lined out here, at least the top three. But the first was reliability. When you have a single sensor deployed at a odor control monitoring point, you have a single point of failure, right? So if that sensor goes bad, you're at the whim of the availability of a service technician or an Aqua Pro to go out and replace the sensor. So now you've not got continuity of monitoring, which is oftentimes necessary for service agreements. Moving on to the safety aspect, again, a single sensor design exposes technicians and the customer to additional risk, right? We've got a number of applications that are, maybe the odor control monitoring point is in the middle of a busy road or intersection, and we have to ask for traffic control to replace those monitors, right? So if it's a single sensor, we're doing that, at best, maybe every 30 or 60 days, but oftentimes it's more often than that if the device fails. The point here is that there's just inherent risk in handling and deploying these things. Another aspect of safety is the continuity of measuring does ensure real-time notifications to hydrogen sulfide excursions, right? So thinking back again to the exposure risks of hydrogen sulfide, the exposure risks of infrastructure failure, continuous reliable monitoring ensures that we're able to respond to those types of situations to ensure that your community is kept safe. And finally is the value piece of it, right? So off-the-shelf devices are expensive. They change hands multiple times from manufacturing to us deploying them in your collection system. And that makes it difficult to deploy them ubiquitously. It's just not always economically feasible to put a hydrogen sulfide monitor at every point. And the other point was that they're not actively being improved. We recently, the vendor that we have been using, released a new device that did make some marginal improvements, but came with a new set of issues, unintended consequences of some of these improvements. So we at Xylem elected to design our own hydrogen sulfide monitor. So addressing all of these issues, we elected to make a device that had 6 integrated sensors. They're all mechanically and electrically isolated when not in service. And we will place one on service in turn on a predetermined interval. All right, so we're able to monitor hydrogen sulfide levels and check for excursions up or down that either are suspect because of sensor failure or because of changes in wastewater parameters. If we're able to make a determination that it was a sensor failure rather than mobilizing an ORCA Pro service technician and asking for traffic support, we can just advance the device to the next sensor and not interrupt the normal course of business. Finally, there were some issues with the other off-the-shelf devices that just did not lend themselves well to this type of a service. Namely, if it's a device that's communicating remotely with some sort of cloud or web-based platform, the off-the-shelf devices have to be set to transmit and then deployed into a manhole or a wet well after they've been provisioned to start communicating. And the difficulty there then is that you have to wait for the device to actually call in maybe 4 hours, 10 hours, or a day later as it's deployed to make sure that it's actually communicating. With the VaporLink 2.0, we've eliminated that. So we're able to deploy the device and then using a mobile app, communicate and provision the device to check the cellular signal, force it to communicate, and make sure that it's able to actually transmit out of the wet well. Here I'm sharing a few key pieces of information from 2 typical wastewater odor control applications. Each of these sites come from different utilities. One is in the northeastern United States and the other is in the Midwest. Each application is typical of what you might expect to see in a wastewater odor control application. They're mostly residential flow, maybe some contribution from a laundromat or a microbrewery, and both of these are treating fairly high volumes of wastewater. One is treating around 4 million gallons per day, and the other is treating 7 million gallons per day. The section of the arrows in this table indicate how a particular parameter changed, and the color indicates whether that was an objectively good or not good change. I should also note that this comparison wasn't made against the preceding 11 or 7.5 months, but rather we looked at the same time period the previous year, so that eliminates any seasonal variability in this analysis. So for the first dosing point, you can see that the volume of chemical delivered with the ORCA pod increased by 2%, which would be objectively not good for a price per gallon program, right? But in a flat fee program, that additional cost would be incurred by the service provider. So more chemical delivered means more cost, but if we look a little bit down the table, you'll see that there was 1 fewer instance of not meeting hydrogen sulfide compliance goals. And in the next row of the table, we see that maintenance, on-site maintenance that is, was reduced by 72% with the new platform. So the major change being here that the metering pump maintenance changed from 11 instances to 2 instances. So this is a direct improvement to uptime. We've selected to use a more robust pump that gives us a lot more information that we can consume remotely to make maintenance decisions and dose rate adjustments to ensure that we're maintaining compliance with our odor control goals. So I guess conversely, the chemical flow meter is a new component, right? So it required no maintenance with the previous model. So any maintenance for flow meter would be new maintenance here. Important to note is that remote interactions changed from a minimum of weekly as the chemical dose rates are continuously being optimized. And finally, the instances of non-compliance with hydrogen sulfide control objectives, again, changed from 4 instances to 3 instances. So moving on to the second case, the first thing you'll notice is that the total gallons of chemical delivered dropped by 28% over the 7.5 months that this system was, that we're looking at with this analysis. And the total number of chemical deliveries for that time period dropped by 3 from 15 to 12. So there's an important distinction because gallons delivered equates to cost, while number of deliveries made equates to congestion in your neighborhoods from tractor trailers trying to drop off chemical. So moving on, you can see that on-site maintenance, again, more specifically pump maintenance, dropped from 8 to 0, again, system uptime. And of course, we added the flow meter maintenance that wasn't required previously. Remote interactions increased to a minimum of weekly to implement our advanced analytics powered dosing optimization, again, the Odor platform. And another important point to make is that these remote interactions refer specifically to touch points with the system. It's not, oh, we're checking to see that it's that we're complying with goals. It's specific touch points. The ORCA system is being monitored 24/7 for pending alarm conditions and process control. But the increase in remote interactions refers specifically to dose rates, adjustments for optimization, or remote troubleshooting. So this is analogous to having a service technician on site doing things. We're now able to do it remotely. So finally, the ORCA pod installed at the second site, we were able to achieve a 66% reduction in the number of instances of non-compliance with hydrogen sulfide targets. So the takeaway here is that the ORCA pod, the implementation of a Water1 ORCA odor control program, we're able to successfully manage and optimize odor control chemical dosing remotely while maintaining or improving on hydrogen sulfide compliance. All right, so this will be our final poll for the presentation. So bear with me for a moment while I launch it. So the question here is, what aspect of an ORCA outcome-based program are you most interested in? You can see we've got a pretty good split here. Two clear leaders. First, we've got continuous optimization with the odor for those that value efficiency. 28% not sure. It's just a lot of information to take in a short period of time. 18% are interested in the total package. These are the folks that know value when they see it. 12% like the ORCA pod, they're interested in precision, and 8% are most interested in the VaporLink 2.0. These are the folks that value transparency of outcomes. I guess to wrap up this webinar, Water1 services offer our customers a unique solution to their water needs by combining key technologies with outcome-based water guarantees, and using remote monitoring, Xylem can provide proactive and predictive services to maintain your odor control needs with a Water1 ORCA program. And by combining data intelligence, proactive service, and over 100 years of experience in treating the world's most challenging water problems, we can provide you with a solution-oriented program and guaranteed outcomes at a fixed budget. So if I could just leave you with kind of 3 things from this presentation, they would be that Water1 ORCA programs are a unique solution. They do combine leading technology with outcome-based guarantees. The Odor Advanced Analytics Platform ensures compliance with your odor control goals by enabling remote monitoring and continuous optimization. And finally, the robust ORCA pod maximizes odor control program uptime through predictive maintenance and data analytics. And with that, we will move on to the questions section of the presentation. We got, looks like a couple of questions coming in. See, we have a question. The state of Colorado, like most states, consider collection system to be a component of the publicly owned treatment works. Therefore, a chemical evaluation form of any chemical added to the collection system is required in addition to the SES. The division has requested whole effluent toxicity evaluation for the chemical. Is your organization able to assist with this documentation? Yes, we've done this in the past with other states. Some of the more progressive states think this way, and when we think about discharge limits and ammonia, we've helped with total mass balances and toxicity evaluations. So we can absolutely do that. All right, we have a question. Can this system be added to an existing bioxide system? In short, yes. I mean, bioxide is the legacy of ORCA, now Xylem flagship solution. So it's absolutely compatible with bioxide. As a matter of fact, the ORCA system, the ORCA program, is compatible with most of our chemicals. There are a couple of things that we have that, just because of compatibility issues or, slurry-based products are more difficult to feed, and we wouldn't run through an ORCA program, but absolutely bioxide, any calcium nitrate, really, iron salts, oxidizers like chlorite or hydrogen peroxide. We would have to build a stainless steel piping system, but that's also in the roadmap. What chemical do we use? That's kind of riffing off of the previous answer. It's all of them, primarily calcium nitrate, but we do have in our portfolio a number of different oxidant solutions. I mentioned sodium chloride and hydrogen peroxide. We use iron salts. We have pH shift products like calcium hydroxide that we can use as well. How do you deal with precision dosing of magnesium hydroxide when the product clogs when not in use? We don't sell magnesium hydroxide, but any slurry-based product we would not run through an ORCA pod. Between the flow meter, the way that it works, we couldn't do that. So we would have to think through for our slurry-based products what we would use and how we would address that. So we have it looks like a common guarantee pricing for 12 months over the course of the contract duration. Yes, so we would enter into a fixed agreement to provide odor control services at a fixed cost month over month for the duration of the contract. So it ends up being incumbent on Xylem to make sure that we're meeting the odor control goals, and if that means that we have to feed more chemical, that's what we do. How do your costs compare with a standard bioxide service agreement? So there's a higher level of service here with the Water One ORCA program, but generally what we try to do is make it cost neutral to the end user. But depending on what types of outcomes the end user is looking for, we would enter into kind of a negotiation and proposal phase of designing this solution, right? So I guess what I mean is right now, if you've kind of loosely got control over an odor control program, but you want to have better control, and we establish targets that are a little more stringent than what you might be using now, that'll affect the cost. If you've already got pretty good control, but you just want to have the fixed budget, the continuous optimization, we can generally do that at no change in net cost year over year. How do you decide what chemical to use? So we have a network of internal engineers that design our application. So they'll receive kind of what we call discovery information for the application, and we'll assess what is the most cost-effective and technically efficient product for a particular application, and then that's what we propose. And of course, we consider, you know, if the utility has aversion to certain types of chemicals, like, you know, if you don't want to have strong oxidizers on site, we might not propose hydrogen peroxide, for example. How does Xylem address odor and H2S control dosing when multiple entities upstream discharge a variety of water, wastewater treatment? In odor H2S treatment chemicals, that's, yeah, you know, the more complex the application, the more interesting it is. And we do have, you know, decades of experience with this, so we're pretty good at it. We rely very, you know, much on our technical folks to design the application. We may, you know, reach upstream and install additional chemical metering points to control at a combined discharge point. And, you know, we can also aid in conversations with multiple utilities if you've got, you know, neighboring utilities contributing to your compliance point. But it does become a bit of a, you know, balancing act. Is everything discussed compatible with the existing link to site service? It is, right? So the link to site interface for the ORCA pod will look a little bit different because there's a lot more information that we like to share, that we're able to share, but it's absolutely compatible. Now the odor platform, so the continuous optimization piece, is separate and standalone. So the kind of the secret sauce there is we've got a group of program managers that are operating that platform, so we maintain control of that. But you still get to, you know, would see the changes made to dose rates and the impact. So we, you know, again, value transparency to what we're doing and are happy to share, you know, that visibility with you. Can the system be scaled down to be used at small lift station? Yeah, that's actually in our product roadmap right now. We're looking at smaller solutions, more compact solutions. So I don't recall if I had a slide that shared what the actual dose rate we could achieve with the ORCA platform were, but it's, you know, peak dose rates up to 4,000 mils per minute and average dose rates of 2,000 for the larger system and then 1,500 for the smaller system. But turn down on these is, I mean, you can pretty much go all the way down. So it's, yeah, we can address most applications with these, but we do see the value in having a system that can address extremely low dose rates as well. Are all of the chemicals available by Xylem compatible with the modeling with the I think that's the question is, can we use the advanced analytics to optimize chemical dose rates for all of our chemicals? The answer is yes. So it's independent of the chemistry that we're using. The odor software looks at the immutable characteristics of a collection system, so like the collection system diameters and lengths, things like that, and then consumes like variable information, so hydrogen sulfide compliance data, wastewater flow rates, chemical dose rates, and other kind of dynamic information that we can feed into the system. And so it doesn't really care about what chemistry we're using. It cares about how changes in dose rates are affecting, changes in dose rates and wastewater flow rates and other parameters are affecting the outcome. And then we get the last question here. I think we're going to have to wrap up because we've gone over, is what is the price point for small lift station? I will move on to the next slide here, right? So you have my contact information. Please feel free to reach out to me if you have any questions. If you're looking for information on pricing for a specific application, I'm happy to work through that or get you in touch with the people that can do that. Or if you have any other questions that have come up from this webinar, I'm very happy to chat and share my thoughts and kind of the other things that we're doing with odor control technology